Hyperloop is an advanced transportation technology, first proposed by Elon Musk in 2013. It is a high-speed system that can transport passengers or cargo from one location to another at nearly 1,200 kilometers per hour, about 760 miles per hour. This makes it significantly faster than conventional trains, airplanes, and even high-speed bullet trains. The core concept of Hyperloop involves capsule-shaped pods moving inside a low-pressure tube, powered by electricity or magnetic forces, with minimal air resistance and friction. Scientific basis. The science behind Hyperloop is based on several fundamental physics principles, including vacuum, magnetism, aerodynamics, and energy transfer. Let's explore these principles in detail. 1. Low-pressure tube near vacuum tube. One of the most crucial components of Hyperloop is its low-pressure tube, which creates conditions close to a vacuum. Under normal atmospheric conditions, air pressure at sea level is 101 kilopascal. However, inside a Hyperloop tube, this pressure is reduced to around 100 pascal or even lower, meaning the air density inside the tube is 1,000 times lower than the Earth's atmosphere. From a scientific perspective, reducing air pressure minimizes air resistance drag. In traditional transport systems like trains and airplanes, a significant portion of energy is spent overcoming air resistance. Hyperloop eliminates this energy loss, allowing for high-speed travel with lower energy consumption. 2. Magnetic levitation maglev. Hyperloop pods levitate above the ground to eliminate friction with the surface. This is achieved using magnetic levitation maglev technology, where electromagnets lift the pod inside the tube. Scientifically, when opposite poles of magnets face each other, they repel, and when like poles face each other, they attract. Hyperloop uses this principle by placing magnets on both the pod and the tube walls, creating a force that keeps the pod floating in midair. Additionally, controlled electromagnets generate the thrust needed to move the pod forward. This method is highly energy efficient because there is no physical contact with the ground, reducing energy loss due to friction. 3. Linear induction motor. To propel the Hyperloop pod forward, a linear induction motor (LIM) is used. Unlike traditional rotating motors, LIM produces motion in a straight line. It generates a changing electromagnetic field, which interacts with the conductive parts of the pod, pushing it forward. This principle is based on Faraday's law of electromagnetic induction, which states that a changing magnetic field induces an electric current in a conductor. In Hyperloop, an electromagnetic field inside the tube interacts with the pod, creating thrust and allowing high-speed travel with minimal moving parts, reducing maintenance needs. 4. Air compression and air bearings. Some Hyperloop designs incorporate a compressor at the front of the pod to manage residual air inside the tube. This compressor pushes excess air towards the bottom of the pod, serving two key purposes: further reducing air resistance, making travel even faster and more efficient, creating an air cushion air bearings under the pod, which helps in levitation. This concept is based on Newton's third law of motion, action-reaction principle. When the compressor pushes air backward, the pod moves forward. This improves both speed and stability. Energy and environmental benefits. Hyperloop aims to be a sustainable transportation system powered by solar energy or other renewable sources. Solar panels can be installed on top of the tubes to generate electricity during the day, which can then be stored in batteries. Because Hyperloop operates with minimal friction and air resistance, it requires far less energy than conventional transport systems. Additionally, since it runs on electricity rather than fossil fuels, it can potentially achieve zero carbon emissions, making it an eco-friendly alternative to current transportation methods. Challenges and scientific issues. Despite its potential, Hyperloop faces several technical and scientific challenges. Maintaining a vacuum, keeping a low-pressure environment inside a long tube is extremely difficult. Even a small leak could disrupt the system. Advanced vacuum pumps and durable materials are required to maintain stability. Heat management at high speeds. Friction between the pod and the tube walls can generate heat. Efficient cooling systems are necessary to manage this issue. Safety in case of an emergency. Evacuating passengers from a low-pressure tube would be challenging. Special emergency exits and safety protocols need to be developed. Cost. building Hyperloop requires a large investment due to its need for advanced materials, powerful magnets, and specialized infrastructure. Future potential. If successfully implemented, Hyperloop could revolutionize transportation. For example, a journey from Lahore to Karachi, which currently takes 12–15 hours, could be reduced to just 1 hour. This would save time, boost economic activity, and improve connectivity between cities. From a scientific perspective, Hyperloop could lead to advancements in materials science, magnetic technology, and energy-efficient systems, benefiting other industries as well. Conclusion. Hyperloop is a game-changing innovation that applies fundamental physics principles to reshape the future of transportation. Near vacuum tubes, magnetic levitation, and linear motors make it possible. While there are challenges, overcoming them could result in a fast, cost-effective, and environmentally friendly travel system. Elon Musk's vision is moving closer to reality through scientific research and technological development, and Hyperloop may soon become a key component of modern transportation.